All right, section 2, troubleshooting basic hardware issues. We've now moved away from troubleshooting configuration to troubleshooting hardware. This one's going to be probably one of the most difficult for most people to try to do in a lab, because unless you have physical hardware from F5 in your labs to play with, it's hard to run an EUD. You can't run an EUD on a VE or a virtual edition. So for all of you online who are watching this video are going to be trying to do a VLabs for your study for this exam, don't panic. Okay? Just because I can't run an EUD on my VE doesn't mean I can't get the grip of what running end-user diagnostics or EUD really is. So one of the things they want you to do in 201 is perform an end-user diagnostic. The way we do that is we're going to reboot the F5 platform into EUD. This is where it falls apart for VE, because VE is software only, right? So if I reboot into an EUD, I'm no longer in the hardware and I'm no longer in the software for us to run. The way we boot into it is we can either attach a USB CD-ROM drive containing the bootable image on a CD, and as the system boots up, the EUD will start if we're booting from that location. And there is a solution around running EUD on hardware out there for all of this, and if you want to, you can, I think I mentioned it and it's in the study guide, you can go read through all of that solution on how to do it out there in specific detail. I'm just giving you the high levels here. You can also attach a USB mass storage device just like you would of the CD-ROM device, and as it's booting up and booting from that device, it'll boot up into the EUD. And then while the system's booting, you're going to select end-user diagnostics from the boot menu, and it'll come up. Once it's up, it's actually a menu-driven system that lets you run diagnostics tests on the hardware of the boxes, of the platforms. So you're going to have about 17 tests here, individual tests that you can run. I actually clipped it, made it shorter so we could get it up into the screenshot. But as you can see, you can do things from systems reports, LED tests. You can test your SFPs. Let's say for whatever reasons you think you're having a problem with some of the light interfaces on your box. You can actually go into EUD, boot the box into that platform, into EUD, and you can run your SFP test number 3 against the hardware, and it'll run diagnostics hardware tests against all your SFPs and give you output from that to tell you what's going on with them. You could run an all tests either with user intervention or without, and once you're done running whatever test you need to run, you can quit out of the EUD and reboot the system back and choose your boot location to boot back into your operating system like you were before to get back into the system. Now, of course, you're doing these EUD tests because you think you have a hardware problem. And maybe even you said, you know, I've got a hardware problem. I'm going to open a ticket with F5 and see if they'll give me an RMA because I think the hardware is bad. F5 is going to make you run an EUD against your hardware if it's possible to run the EUD. Now, when might it not be possible to run an EUD against your hardware? Well, if the box is dead and will not power on, and there's no way for you to power it on and get into the box, there's obviously no way for you to run an EUD test. But any time that the box will power on and is running, it's probably capable of you running an EUD. Now, maybe the hard drive died in the system, and you think, well, there's no way for me to boot up into the hard drive, there's no way for me to boot into the system, but if I'm booting from a USB CD-ROM or a USB MEM stick, I can still run EUD from there. So there is a way for you to do it, and the solutions out there will walk you through it. But what you've really got to probably have key information about for this exam is that how you get in and boot it up, what tests are out there, not necessarily every single one and what number they are or anything like that, but when you run a test, what does the output look like? So, you know, if I have run the exam or run the test on the hardware, I should see an EUD log in the shared log directory on the host file system. Now, that's assuming that I've got a hard drive that's alive, obviously, things of that nature. But that log file should be available to you in shared log. And if you're looking into that file, that log file, and reading through it, if you see the output saying completed test with 0 errors, you're probably not a happy person. Because if you think you have a hardware problem and the EUD is telling you you do not have a hardware problem, it's unlikely you're going to get an RMA for that problem. Probably means you've got a misconfiguration in your OS configuration for the config on the box, or it could mean that maybe you didn't read the release notes as well as you should, and there's a known issue with that release and this type of configuration on the platform Could be something to that effect, not necessarily a hardware issue, but it may manifest that way. So this is one way to rule that out. Of course, anytime you run an end user diagnostics, you're taking a unit in your pair, or hopefully a high availability pair, and you're having to reboot that box into EUD to run the test. So you need to be scheduling this as an outage. You need to be going through and doing all your typical change window stuff within your company that you have to do administratively, because you will be taking a box out of your high availability pair or scale-in environment. And if it is a standalone box, obviously it will be a complete interruption of service while you're running end user diagnostics. When you're dealing with hardware, you need to be able to indicate which logs may contain debug information. So there are different types of systems events on the box, and they get written to different log files in the system. System event logs, packet filter event logs, local traffic events, and this is where a lot of your logging will happen, is inside local traffic. And there are audit level events, and each of these are different types of events on the box. All of those types of events are tied to a local facility, and unfortunately my slide messed with some of my spacing here, but if it's an LTM-based event, it's going to be in a facility from Alert D that is going out to local 0 as a facility within the operating system, and that's going to get written out to varlog LTM. And you should see that everything you have licensed on the box as far as a product will have a log file associated to it. We also have iControl logs. The iControl logs will actually end up in the same LTM file that all the LTM traffic ends up in. We do have a packet filters log, HTTPD errors, the daemon errors, and a boot process log out there, as well as some of the common facilities we have available to write out to files. You will see, like I said, a lot of your traffic going into the LTM log. A lot of the common events like high availability failing over from unit to unit, health monitoring between the big IP and back-end server systems. When monitors succeed or fail, it'll show up and down, and those logs will all end up in LTM. And each of these products that are licensable on the big IP platform have their own logs, but if I'm running an LTM and I don't have GTM or ASM licensed on that platform, theoretically nothing will be written to these logs. They'll typically be empty. But that doesn't mean that this local facility can't still be called and have something written to that log file. I like to usually say when I'm doing iRoll functions on a box and I want to debug one of my iRolls, if I'm on an active system, the last thing I want to do is log my log instances inside my iRolls for debugging to local 0 usually. Because if it is an active unit in the pair that I'm doing some debugging on for traffic, what's going to end up happening is that LTM file is going to get my debug statements from my iRoll into it. And if the NOC is paying attention to the LTM directory, or there may even be traps sent up from the LTM to some monitoring system in the NOC for your support, for the company's support side, they may see all these errors and not understand what they mean and really freak out about it. I typically will log to a licensable facility that's not currently licensed on the box. Like maybe I'll log to the local 2 to GTM directory just out of habit, so that I'm not putting something in the log directory for LTM that may be seen by the NOC and scare some people as I'm debugging some stuff. But these are some of the facilities and logs that you're going to have to get familiar with. You should be able to look at these logs and know what you're looking at. Because if you were given a log file example on the test and they show you a screenshot of a log file, they may ask you, according to what's in this log, what kind of hardware problems was the box experiencing, A, B, C, D, or E. So you need to get familiar with looking through the log files, understand how to read them and what the structure looks like, to be able to be comfortable with what you're going to end up seeing on the exam. All right, given a possible issue, determine which log file entries to review. This is our next bullet point for the 203 hardware troubleshooting section. Kind of a vague point again. Given a possible issue, you have no idea what that issue might be, but determine what log file entries to review. So you need to be able to be familiar with what type of events go in each log. There's some serious reading you can do on this. The study guide gives you some decent reading around this. Some of the points in the study guide you guys might notice say, because this is a hands-on type of a topic, you're going to have to get in and mess with the GUI and get into the interface and just use it to get familiar with it. This would probably be one of those where that is the bullet point topic information in the study guide. If you can't get into the boxes before you take the exam, you're going to be at a serious point where you may miss questions around these topics, because getting in and looking at logs on these boxes will get you familiar with what you're looking at and what possible issues they may present you with. If it's failover related, if it's configuration related, it's probably in the LTM file. If it's packet filter related, it's probably in the packet filters log. These are the things you've got to get familiar with looking at and taking a look at inside the GUI and configuration of the box. Let's perform a failover to a standby box under the appropriate circumstances. So if you haven't done failovers between a high availability pair, you should try it. In version 11, building an HA pair got a little more challenging than it was in previous releases, because we didn't have scale-in available to us. Thus, we didn't have traffic groups and things of that nature when it came to configuration. And HA pairing was as simple as saying, who's your partner box? Okay, we're in a pair. He's my standby, I'm active, or we're active, however you want to do it. But it was much simpler until we hit version 11. So I would highly recommend that if you're building out your VLabs, for this particular section, go ahead and stand up a secondary big IP, get another 45-day key, pair them up in a pair, go through that lab for HA, and get a feel for what a failover looks like. You can connect to your virtual servers, see your connection working, fail the pair over and see if everything is still working as you perceived it should be working. The question here is probably going to be more around the explaining circumstances of when a failover should be used to determine if it's software or hardware related. And because we're talking about hardware failures, it's very common for configurations of a box to manifest themselves and look a lot like a hardware issue. It's not uncommon. But if we wanted to determine if it's hardware related, we could definitely use failover to do that. Because if I have the same exact operating system, same exact hotfixes installed on both of the units in my HA pair, and I have the exact same configuration running on Unit 1 as I do on Unit 2, which means they're in synchronization for config, then if I'm experiencing a problem on Unit A as I'm working, if I were to fail to Unit B and the problem goes away, it's pretty likely that the problem I'm experiencing is hardware related. Now that does not necessarily mean it's hardware related to the F5 Big IP platform. But what it does mean is that it could be related to the hardware in that environment when Unit 1 is running. So it could be the upstream switch, the downstream switch, physical interfaces on that switch that is tied to Unit 1 and not to Unit 2, because obviously you're using different interfaces between the two boxes on the switch, even if you are in the same VLANs and networks. So you could definitely determine if the problem is hardware related by doing a software a failover between an HA pair. If you do fail over and the same exact problem is manifesting itself in the other box, chances are it's software related. It could be, like we said before, it could be your configuration problem, it could be a OS release known issue problem that you missed in the release notes, or it could be a combination of the two together causing the issue. Use failover as a troubleshooting step in an appropriate situation. This would probably be the only situation where I would probably use, as an SE, failing over between boxes to troubleshoot a problem if I suspect it's hardware, but I'm not sure if it's hardware or software. The reason for that is because failovers can be hitless, but at probably no time are they 100% hitless. In a big IP platform, we are not stateful by default. You as the administrator of the box, as you're configuring all the configuration of the box, have to say, I need these sessions for this application to be stateful between the units. This is called connection mirroring. On a per virtual server basis, we do connection mirroring. Also, if you're using persistence, like source adder-based persistence, you're going to want to say, if I'm using this source-based persistence profile on this virtual server, I want to make sure that all the source-based records that I have for that virtual server as they're flowing through the box actively are being written to my peer box. I want to mirror those connections over there, because if this box were to fail and this one were to take over, he needs to understand that I had a persistence record and I was already sending that user to server 6. So by default, we don't do that. And I have a lot of students ask, why don't we just do connection mirroring in these settings by default? The simple answer for that is you don't have to buy two big IPs. you only have to buy one, right? It's up to you as a company to say we need HA, we need a true HA, we need a pair at a minimum to have a full HA environment. You could say I just want one big IP platform. A single big IP platform will do the job that it's meant to do all day long without a partner box. The problem is that if the hardware were to go or you were to have a critical problem, he has nothing to fail to from that platform. So if we were to turn on connection mirroring by default, there would be nothing to connection mirror to if there's not a secondary box there. That's why we don't turn it on. All right, section 3, troubleshooting basic performance issues. Now we're getting into why is my box slow? So if you haven't done this before, you need to get very familiar with performing a packet capture. If you haven't done a TCP dump in your past, you should get very familiar with doing it, how it's done, get comfortable with running the commands and gathering the data, and then once you're getting comfortable with using it, you need to get very comfortable with reading it and getting comfortable with looking at the output. It is a big part of administration of a big IP system. It's a big part of just being a network engineer, is to be able to understand what's going on the wire in your network. So TCP dump is available to you on the big IP platform. I don't know that I have any command examples up here, so I might do some on the whiteboard here. But basically when you're issuing the TCP dump command, you're going to define an interface for you to capture traffic on. You're going to give it the switches necessary to capture the appropriate type of traffic. You can filter down on host and port and use Boolean logic to help you determine a good strong filter against the traffic. You're going to write that file out to a binary file, so possibly you can open it up in Wireshark and take a look at and analyze that data a little bit more with maybe filtering there. You can even come back and do a -R and read the file flat once you've written it out. So if we go through some of these switches, what do they mean? If I do TCP dump -I, I'm going to define my interface. Now what interface do I define? It's always the trick when you're doing TCP dump. Where do I capture traffic? Where do I really want to capture traffic? I would always say if I know specifically my traffic problem that I'm having or I see is happening between user A and server A on the back end, client A on the front, server A on the back, those are two separate VLANs more than likely in my architecture, and I want to do my TCP dump on the interface that is that VLAN. But there's other ways to capture this traffic. A lot of times if you open up a ticket with F5 and they say, hey, could you get a capture of this traffic so we can see what problems might be going on and help you with that, they may want you to TCP dump on interface 0.0. Now you can TCP dump on any of the physical interfaces on the box. I could TCP dump -I on 1.1 and just capture traffic on 1.1. But when we start talking about architecturally deploying the box, 1.1 might just be a single interface within a trunk, right, or a port channel in Cisco's world, or Ether channel. So that one might be bound together with others, and we only grab a portion or maybe even a slice or not even a part of the traffic that we want to get. I could TCP dump the trunk interface name if I wanted to, -I, the name of the trunk interface. But if we do, and like F5 will typically recommend, do a -I 0.0, that's actually the loopback interface on the box. It's going to TCP dump all interfaces at once. Now, is this a great thing for you to do? Well, in the middle of a production day when you're experiencing the problem, you might not want to TCP dump all interfaces on the box. That might not go over so well. I always like to tease in the class, that could be a CEE or a career-ending event for you. You want to make sure that you're TCP dumping what you need. And of course, if I do a TCP dump on 0.0 as an interface, that loopback, I could still filter down and use my host filters and IP and port filter logic to say, okay, don't capture everything, capture on all interfaces, but for only that client's IP traffic on these ports going to this server's IP traffic on these ports. And even though I'm looking at all interfaces at once, I'm only capturing a small amount of the data flowing through the big IP system. So you definitely want to be able to make sure you're capturing where it's appropriate. And the more specific you can get, the better. So if your interface is broad, you probably want to filter down with some host port logic. If you're able to do an interface that's only VLAN 100 and 101 rather than the 50 other VLANs you have attached to the big IP platform, that's good too. I can do the -E and show Ethernet. Now you say, well, what am I showing Ethernet? What is that doing? We discussed at layer 2, the very first section of the 101 was what is a MAC address. So this -E is going to show us the MAC addresses, right? It's going to take us down to the Ethernet level as far as descriptions go for the clients. That could be good. And maybe if I have a dual path environment where I have multiple upstream routers and I'm seeing a weird quirky problem, if I do maybe a -E here, I might see that it's only coming from one of the two MAC addresses that are my head-end routers, right? I can distinguish that maybe it's only happening when I'm on path 2 and not on path 1. -N says don't convert addresses to names. I don't want to do name resolution there. -X shows me the ASCII hex. -R lets me read a file. -W lets me write to a binary file. -C says counts. -C says, okay, I'm going to capture the next 1,000 packets, so -C 1,000. I know I don't need to capture a ton. I'm just going to run it for this period of packet count. That's what a -C would do for you. If I do a -S, that's our snap length. How much of each packet do I want to capture? So there's a couple of different ways to do -S, and you should always do a -S command. Even if I don't do a count, I can just break the TCP dump whenever I feel like I've got enough of the capture if I didn't put a count command in. But when I'm doing snap length, I'm saying here's how much data I need to collect. So if I need to see HTTP headers, right? I need to look into the HTTP headers. I need to see them. If I just don't type a -S and I let it run, I kick off the TCP dump without a snap length defined,
I'm only going to grab the first 68 bytes of the packet.
Because that's the default gathering that it's going to do, and that's really just your TCP headers. So you're not going to see your HTTP headers, which are further back in that packet structure. If I need to see those HTTP headers and I didn't define the snap length, I'm probably not going to see them. So what do I need to do? I need to set a snap length to let me gather that data. Maybe I've got to set a higher number of bytes. Or if I do a -S, I'm going to grab the entire packet. Some would say here you should do a 1500, -S 1500, but that's really not going to work either, because if it would grab the first 1500 bytes of a packet, and if we were truly using an MTU in our network, that should grab every packet on the wires fully, completely, right? It should. But if you have jumbo frames on your wire, and maybe they're what's causing the problem in your network, it's going to truncate off at 1500 bytes, the jumbo frame, and then that jumbo packet won't be recognizable because you've shortened it, right? But if you do a -S, it's going to grab all of it, no matter how big it is or small it is. All right, I think that's enough for the basics on TCP dump. There's a lot of command examples you can find out there on the internet. They're very easy to see and find. It's the standard TCP dump command that we have available to you on the Big IP platform. So let's move on. Determine an appropriate location to take the capture. It's always critical. Like we talked about our interfaces, make sure you're dumping where it's appropriate. Doing all interfaces in the middle of production day, you could start losing packets in the collection. So Big IP is dedicating resources to moving your packets through the box and getting it out to its resources on the back end. You do a TCP dump and he's under heavy load, he may stop writing every packet to your file. Thus it looks like not everything's going on in your TCP dump that was actually happening through the box. You can cause overhead problems that can cause congestion on the box too. So you want to be careful and try to filter down and capture where it's appropriate. Now that doesn't always mean that you're doing the TCP dump on the Big IP platform. If I have a network tap out there and I have another analysis tool, maybe I'm running Wireshark on a laptop and I've got it into the network and I can do the capture there, that's great too, if it does what you need it to do. On the Big IP platform, you can actually kick off more than one TCP dump at a time. You got to remember, it's Linux operating system, so you have all those same cool commands, right, that Linux can give to you, available to you when you're doing TCP dump. So if I put an ampersand at the end of my TCP dump, it'll actually put that job in the background and take it out of the foreground so that you can get back to the command prompt of the operating system again and maybe kick off a secondary TCP dump on a different interface so you can up two at the same time. And then just bring those jobs back to the foreground again by doing FG, and then you can break the captures if you need to. But doing it where it's appropriate is important, and that doesn't always mean that you're doing the TCP dump on the Big IP. You may be doing it on other analysis tools. If your network environment has a NAM from Cisco in the switches and the cores, you might be able to get your captures there. It just depends on the environment for the user or for that company. The appropriate time to take captures. Obviously you want to capture when the problem is happening, right? Not always possible, because sometimes by the time the problem's happened and you realize it's happening, you go to get a capture and it's already stopped. Very, very common. I could give you a solution for that. It's called iCall. That F5 has available. Now I can do an event-driven type stuff, but I don't want to get into it because it's really not a part of what's going to be on the exam for the 201. It's really relatively new stuff past 11.1. It's good to know when to take your captures, though. You may get an example of, I'm having a problem with this type of an issue in my network. We want to do a TCP dump. Where should I take the TCP dump according to this diagram? And you'll have to say these are the interfaces that need to be captured. And maybe if 00 is an available interface, that's the appropriate one. But it may say in the question, it's the peak of the day and blah, blah, blah. We're under high load. I need to capture this data. You need to try to filter down and more specific captures when. Broader captures are dangerous, right? Appropriate tools to use. Once again, TCP dump on our big IP platform. Capture tools out on the network using taps, network taps to get in line, things of that nature. Make sure your packet capture tool has the capacity to capture your data. If I'm going to be doing a snap length of 0, I'm capturing all of every packet and writing it to the file. I could run out of disk space very fast on no matter what platform I'm on. I could be on some other platform in the network doing the capture. Just make sure that when you're doing your captures, however much data you're writing, you have the capacity to capture that, and you don't end up tipping that box over or causing an issue for that server that you're doing it from, or the big IP platform for that matter. Narrow your scope. I feel like I'm beating that dead horse here, but this is what they're trying to drive home. Make sure you're filtering down and narrowing the scope of context that you're gathering on your packet captures. And if you can remember that rule, you should always be able to find the most specific answer in your multiple choice questions. You may be given a scenario that says, I'm trying to figure out if this is the problem. Should I do a packet capture? Packet captures aren't always the answer. Sometimes I can look into statistics on the box and find out exactly what's going on from the statistics without ever having to actually do a capture. I don't want to say a packet capture is your last option, but it shouldn't be your first. There are other tools available to you and other places to go look at information to try to solve problems within your device, your big IP platform. All right, objective 302. Still using our big IP to troubleshoot potential performance issues. This section is going to ask us to differentiate between different performance issue types like latency and congestion, broken content. Huge differences between latency and congestion. And if you guys are network engineers watching this, you're very familiar with what I'm talking about. Latency is actually describing time delay of transporting data between one point to another. And this is usually, physical distance limitations. There are physics involved here. There's traveling from Florida to California, it takes time to get there. Even at the speed of light, you're not instantaneously on the other side, and it takes seconds, milliseconds, sometimes across networks, and that is causing what we call latency. Other things can introduce latency as well, though. Things like SSL handshaking or bulk encryption, de-encryption for SSL, or just TCP session management when you're that full proxy architecture. You're in the middle. You're actually taking stuff, processing it, and reprocessing it. That can introduce latency. The key is to have really, really low latency on your devices. And the difference between latency and congestion is actually occurring when a network, a node on a network is processing so much data that it's overwhelmed or can't process it all. I don't know if any of you guys have ever experienced a bad NIC on a system, on a workstation or on a server, but the amount of trash it can dump onto the wire can really disrupt traffic on your network for sure. And that's what congestion is all about. It's all about being able to process the amount of data being taken in by the system. Broken content can manifest itself in the same way that latency or congestion may be manifesting itself to the end user, in that I can't get to a resource, or it's taking a long time to load the page, and then the page just seems like it never loads. And that could be broken content. And when we say broken content, we think about I'm pointing to a location and asking for a file, but that file doesn't exist in that location, so the server has no way to return that file back to me. And it tries to find it, or maybe it's looking for it and can't get to it, and then it gives an error, file not found, or something to that effect. And that time of it trying to load the data that it can't find can manifest itself in being slow. Because what is the user going to say? It's not going to say, hey, I'm experiencing latency. The user's not going to say, hey, I've got some congestion going on today. Can you help with that? They're going to say, man, things are really slow, right? And then they just seem to time out. Well, if you've got a lot of latency, sometimes things will time out. It'll go slow and then time out. And if you've got broken content, it seems like it's going slow because it's not finding it, and then it times out. So that manifestation of the problem could be the same to the end user. So you've got to be able to determine what the differences are in the architecture of your network, what could be causing the problem, and how to troubleshoot from there. Establish the frequency of a given issue. Is it random, continuous, isolated, intermittent, repetitive at intervals? I'm not your dictionary. I'm not going to sit here and define each one of these words for you when you could just simply look them up, and I think we describe each one of them in the study guide. So I'm not going to spend a lot of time on this bullet point. Just understand what each of them mean, because as you're asked questions on the test, it could say, hey, your customer is experiencing a random problem. Well, understand the definition of random so that you can probably try to figure out what the right answer might be on the test. Explain how to get performance statistics in addition to those shown on the dashboard. Basically what they're telling you to do is, where else can we see statistics about the performance of the Big IP platform? And where you could go is overview performance. So like I said before in your screenshots, your left-hand menu in 11.1 is overview. You're going to go into the sub-menu of performance or statistics performance, and you're going to be able, if you're on the new versions, and you're going to be able to see the Big IP platform as a whole and how it's performing, from memory utilization to disk utilizations, how TMM is performing, that's our traffic management module, how basically the operating system is working as far as a kernel on the box. So you can go back and look at your graph interval of 3 hours up to days. You can set your graph interval that you want to use here, so you can see trends. Maybe you're seeing a spike right now, but if you are looking at a 3-hour view and you see a spike, you can say, well, hold on a minute, I'm going to view out to a 7-day view, and you see that every 3 days you see a spike, and we're at that 7-day mark. Maybe it's not something that's unheard of, right? The spike you're seeing is typical for your network. Just depends on what you're looking for. You do see statistics in the dashboard, and I have had some students tell me that they had some questions around dashboard shots, and they wanted us to explain things that they were seeing in the dashboard. But I also want you to understand that you can go into the performance section and see all these same amounts of data on statisticals of what's going on inside the Big IP platform, and at MRTG-based stats. They're all graphed and very visual for you.